All right. So let's talk about Revit. The first thing I do want to say about Revit is I've learned that working in a Revit project and teaching a course in Revit, the process is actually really similar. And you're going to find that out you've already found that out, really, in that you won't have any assignments for the first couple weeks because Revit, and I'm going to compare it to AutoCAD a lot. So for those of you that have had AutoCAD, that's fine. For those of you that haven't, you're not really missing out on a whole lot, right? But with AutoCAD, we can jump right in and we can start drawing, right? There's not a ton of definition that needs to go on before we start working. With Revit, there is a lot of definition that needs to go on before we start working, which means you won't have assignments for a couple weeks. The process of working through a project in Revit is very front-loaded, and the process of working through an AutoCAD project is very back-loaded, essentially, right? So in Revit, you're going to find we move kind of slowly in the beginning. We kind of creep through all of our initial topics, but in the end, everything just moves very quickly, and we wrap up the semester and our final project very quickly. Whereas in AutoCAD, we kind of go very quickly in the beginning. We get through a lot of information, but then we kind of hit a point at the end of the semester where we just have a ton of work to do, right? It's very backloaded. And so the same thing happens professionally when you're working. Revit, the process of working with Revit is a very front-loaded type workflow. And when we first started using Revit, my very first full entire project working in Revit was when I was working at AJC Architects, and it was the YWCA Center for Families downtown. And we started working on it, and we were constantly missing deadlines. We were just blowing by them like crazy. And everybody was really worried, and people were starting to doubt whether or not we should use Revit, right? Because it was just moving so slowly in the beginning. And then what we recognized was at the end of the process, we flew through it so quickly that we ended up just right on time, essentially. So there is a lot more work that needs to be done up front, right? But then on the back end, you kind of breeze through it, okay? So I want to talk about the definition of Revit. What is Revit? And to do that, I'm going to talk about, and I'm going to show you, and again, if you haven't had AutoCAD, it's not a big deal, but I'm going to show you the differences between working in a Revit project as opposed to an AutoCAD project, okay? The first thing I want to talk about with Revit is I want to define what BIM software is. BIM, it's an acronym for Building Information Modeling. And Revit is a type of BIM software. Revit isn't the only type of BIM software, but it is probably the industry leader at this point, right? Everybody is sort of using Revit. The term BIM, it's a generic term, just like CAD, C-A-D, computer-aided drafting, right? That's kind of a generic term. People will say, oh, I use CAD all the time. And they're kind of abbreviating the term AutoCAD, but AutoCAD is a computer-aided software, computer-aided drafting software, right? Just like any other computer-aided drafting software out there. But BIM, Building Information Modeling, it's an acronym, and it's a generic term for that type of software. Now, what does BIM software mean? What is the definition of a BIM software? Okay. BIM software is a model-based construction drawing generation software, essentially. So when you're generating construction documents in a BIM software, it's based around a model, all right? And that is, I guess, I'm not going to say unique, I guess, but it's different from AutoCAD in that when we generate drawings in AutoCAD, we're not creating a three-dimensional model that we then view to generate floor plans, elevations, and sections. In AutoCAD, when we generate floor plans, elevations, and sections, we're generating flat 2D drawings, okay? So our lines represent three-dimensional objects that we build in the real world, and each of our drawing files are separate, okay? So for example, here is an AutoCAD file, and it's a floor plan. If I pop this AutoCAD file into 3D, we're going to see that it is flat, right? Totally flat. Let me go back here and get to my top view. All right, I see lines and they have different colors associated with them. The way that we know, even though this drawing is flat, the way that we know that this yellow little region right here is a wall is that there's a specific distance between this line, and we'll get rid of that, this line and this line, right? And we know that the color kind of tells us that it's an existing building shell wall, essentially. So the way that we know that things are walls in AutoCAD isn't because it's a three-dimensional wall like in a model. It's because we have, items that have been offset a specific distance, right? Maybe this says, let's measure this. Maybe we can figure out what it is. 10 inches. I'm guessing maybe it's CMU block with brick on the outside or something, right? But we can kind of guess, well, with a 10-inch thickness for a wall, maybe we have CMU with brick on the outside, okay? Probably a little thicker than 10 inches, but that's what represents a wall in 2D AutoCAD. Lines, offset, and the layer that they're on, the color associated with them, all right? How do we know something is a wall in Revit? Well, it's 3D. It actually looks like a wall, right? I can go into a 2D view. And let me just say this, don't worry too much about knowing exactly how I'm navigating and doing all these different things, because we'll talk about that in the weeks to come, all right? Today is just sort of it's information gathering for you guys, right? You're just gonna watch and I'm gonna show you things and talk about the software, okay? How do I know things are walls in Revit? Well, when I look in floor plan view, I can see my wall right there, all right? And then when I go into a 3D view, I can see my walls in 3D, all right? So my walls are three-dimensional objects, and I know it is a wall also because it has a definition associated with it, which is different than AutoCAD. So in AutoCAD, again, if I want to represent a wall, I take one line and I offset it a specific distance from a second line, right? And that kind of that implies a wall. In Revit, when I create a wall, I draw it. It's a three-dimensional object. But before I draw it, I actually have to define it with a specific assembly in mind. So when you look at walls in Revit, you see that they are actually defined with an exterior finish, a wood stud layer, we have timber structure, and we have an interior finish here, right? So I'm seeing all of these different layers, right, that are part of an assembly that define a three-dimensional wall, all right? So building, information, modeling, we're creating a building. There's information attached to that building, right? This is the information that's attached to that building element. And then we model elements. So they're three-dimensional model elements that I can see when I pop into a 3D view, okay? So that is what BIM stands for, Building Information Modeling. You're modeling a 3D model and it has information attached to it, and generally it's a building project, right? Okay. Does that somewhat make sense, the difference between a BIM, a BIM model, right, and a 2D AutoCAD file? Hopefully it does. It makes sense. All right. So we now know what BIM stands for, and we know what the difference between BIM software and like 2D drafting software like AutoCAD, how they're different essentially. I want to talk about some of the things that go on in Revit, right, that make it a BIM model. All right. So there's building, there's information, there's modeling. I'm going to come over here and I'm going to close out a few of these things here. I'm going to just stay here in my 3D model for a second. But I want to emphasize the fact that when you are creating drawings using Revit software, everything is generated around one 3D model. So here's my model. It's made out of different elements. There's my roof. That's a piece of geometry, right? And if I look over here, basic roof. It's defined as a roof. It's not just 2D flat lines that say that sort of pretend they're a roof, right? Here's a window. I click on it. There's a window. It's defined as a window, right? So it's a 3D object and it's also defined. Here's my railing. I've got a concrete pad here, it looks like. Yep, there's a concrete floor there. I pop in here. I have some furniture in there, right? I've got ovens on the wall and a fridge and an island and lots of good things happening, right? I've got some foundation pillars happening here, right? Some piles going down into the earth. A big thing that I haven't clicked on yet is I have a piece of topography here, right? So I can actually see the site in Revit, which is is a really magical thing that Revit does very easily that AutoCAD does not. Okay, so my construction drawings are all based around this model. All right, and this model is what's called parametric in nature. And parametric in nature means that there are relationships between different building elements within the model. All right, and what a relationship means is that if I, for example, and this is going to be probably, I'm going to get a lot of errors, but we're going to do it. Let's see. What was my scale before? We don't want quite that much. Okay. I'm going to go into a building section here real quick and show you a few things. Parametric in nature means that different building elements have relationships established between one another, which means that if I take this roof and I move it up, I'm getting a lot of errors, of course, but I can move it up, and as I move it up, do you notice that the skylights that are attached to it, they stick with it, right? Because the skylights inherently have a relationship with the roof that they're hosted into. They know that they kind of go together, and so when one moves, the other moves, all right? The wall is not playing very nicely, but it is trying to remain attached to the roof and move up with it as well, right? If I take my door, this door right here, and I move it over a little bit, right, the wall allows it to move, and I don't have any kind of excess opening around it, okay? So parametric in nature means that there are relationships between different objects in the model, okay? That can be good and bad, right? It can be really good if you're an experienced Revit user and use the relationships to your advantage, but it can be terrible when you're a brand new intern going into a big office and you start moving and manipulating things in a model and don't realize how many things move with those objects, right? You move the floor, all the plumbing fixtures move, all the windows move up, all the roof moves up, all the dimensions move, and suddenly people are really starting to stand up at their desks and ask who is wreaking havoc in our model, right? So it can be a really good thing, but it can also cause a lot of problems very quickly, all right? So I'm going to hit undo here and just go back to where we were. Okay. So another really nice thing about the idea of using a model and having the model being parametric in nature is that when you update one thing in the model, it updates in every single view, okay? So if I, for example, let's get two views on my screen here. So I've got my view of this. Let's do a north view. I want to get that front view. Let's see. Yes, this is the view I want. Okay. So one big kind of stumbling block in AutoCAD, one thing that is kind of problematic is, or time consuming, I guess I should say, is that, you know, when you're working, all of your files are separate. So we don't have one model with all of our drawings in it. We have several separate different drawings that we need to open up separately to make changes to. So for example, I have one drawing for the floor plan in AutoCAD. I have one drawing for north elevation, one drawing for east elevation, one drawing for south elevation, one drawing for west elevation. A drawing for the sections, a drawing for the site, a drawing for the, you know, different levels of the project, you know, level 1, 2, 3, 4, 5. What's nice about that is they're separate. So if you change one, it doesn't automatically change all the others, right? But what's bad about that is that if you change one, it doesn't automatically change all the others, right? So every time I change the floor plan significantly, I have to open up all 4 elevations. I have to open up the sections, right? The details, and I have to update them so that they reflect the changes in the floor plan, right? If I narrow the floor plan by 10 feet, I need to open up the elevation and narrow the elevation by 10 feet, okay? But in Revit, when I change something, it changes in all views. It goes back to that idea of parametric in nature. So if I want to take this wall, I'm in an elevation view right now. I'm in the west elevation, right? And I look over here, I have my 3D view open at the same time. You can see that when I select it in one view, it selects in the other view, right? Let's see if I can delete it and wreak some havoc. Maybe I'll just try and move it. But if I'm in my view here and I try and move that wall, right? It moves in all views. You can see it very gently moving over here very nicely, right? So good and bad, because now when I make a plan change, right, it updates an elevation, section, detail. Anywhere where that wall occurs, it's updated. So the nice thing about this is that I'm always working on the most current information. Okay. The bad thing again is when you're that new intern that starts going in and changing things, and it's affecting everything in the drawing set, making people crazy, right? Okay. So I just kind of showed you here that if I move one thing, right, it moves in this view. Another really nice thing about the idea of, BIM software, items having relationships within this software, and creating a 3D model is that when I generate the 3D model, all of the views that I need are generated at the same time that I create the 3D model. So if I am in a floor plan level, let's close a few of these things here. If I'm in a floor plan level like this and I'm drawing away, as I'm drawing these exterior walls, right, I'm drawing the floor plan. At the same time I'm drawing the floor plan, I'm actually drawing all of the other things as well, right? So floor plan is being drawn, but I'm developing elevations, sections, all those things at the same time, all right? I probably said it 5 different ways, but I really want to emphasize the fact that as I create things in my Revit model, right, they're not just generated in one place, they're generated in every instant or in every view that they're needed. Okay. All right. Any questions so far? Okay. So when we look at our Revit model, right, so we have this 3D model, and one of the things that I sort of questioned as I was learning this software is, that's great, right? We're creating this Revit model. So I know that as I generate my walls and doors and windows and things, that I'm creating floor plans, elevations, and sections. That all makes sense. I guess that makes sense, right? So how do I access those things, and how does that system work, right? So I create this 3D model, then how do I look at the floor plan? How do I look at the sections? How do I look at the elevations, right? And the way that that system sort of functions is we view the model differently to see different drawings. Okay, so when I'm working in AutoCAD, if I want to see the floor plan, I open up AutoCAD, I click open the floor plan file, and it comes up on the screen. That's how I view the floor plan. Okay, when I'm in Revit, if I want to see a floor plan, I'm going to view the model in floor plan view. All right, so what that means is that essentially, right, if I think of this as a cube, we can look at it as a cube, all right? If I want to look at a floor plan view of this, or a roof plan, or a basement plan, I'm going to click on the top here, okay? See the top? Click. When I view it like this, I'm viewing it this is actually a roof plan, obviously, right? But this is how I'm going to view different drawings within my model, right? I'm going to view it differently. So if I want to see a floor plan, I go to a top view. Okay, if I want to see an elevation, I go to a side view and I view it from the side. With models like this in Revit, it's all about how you view the model that allows you to see the different drawings in the model. Okay, so I was using what's called the view cube here to navigate around the model to show you the different drawings that are going to be created here. But when we get a little bit further into Revit, you'll see that we use our project browser over here on the left-hand side. It's this little thing on the bottom here, okay? And within this sample model that we have generated, there are a bunch of views already created, but I can click on level 1, and I go to level 1. All right. Now, essentially and there's some other definitions in here that drive this, right? But essentially, I'm viewing this model from the top with the roof cut off at a level 3 to 4 feet above where level 1 would occur. Okay, click on level 2 over here, click. Now I'm viewing level 2, and I'm viewing level 2, I'm looking at the same model, and I'm viewing it as if the roof were cut off 3 to 4 feet above where level 2 would occur. Okay, I've got 3D views created, right? I can click. And we can just click and just start looking through all these views that are generated. But these are viewing the model in kind of a perspective view, right? A camera has been placed, and we're viewing these in a perspective view. Okay, I have my elevation views here, north, south, east, and west. There's north. Okay, there's my north elevation. I'm viewing this from the side, from the north side, right? There's my east elevation. I'm viewing my model from the east side. Okay, sections. Sections are so easy in Revit to create. If anybody's ever drawn a section in AutoCAD, right? It's really kind of painful. In Revit, as you'll find soon enough, they're actually pretty easy to generate. So I'm going to click on my typical wall section. Right? This is as if you were viewing the model sliced vertically, right? We took the building, we sliced it vertically, and we're looking at all of the different assemblies and how they're constructed, right? Okay, you guys get the idea. So we have a bunch of other ones. We have details, we have renderings. Oh, rendering, if you didn't know. I mean, Revit, if you didn't know, has rendering capabilities in it. So if you haven't, I don't know why, we're working on this, of course, too, in our curriculum, but you can take modeling and rendering before you take Revit, actually. So some of you may have taken modeling and rendering, but rendering is the ability to take this 3D geometry and turn it into a photorealistic image, right? So all of that information, to a certain extent, there's a lot of work that goes into it, is kind of built in, right, to Revit. We have materials that we can build in or change. We have the 3D modeling geometry. So if, you know, this is a really great tool because, number one, if you have the Revit software, you have this capability. So one tool does multiple things. But also, you know, our clients aren't always as spatially aware as we are, right? We're generally going into architecture, into design, construction, interior design. You know, we're very visual people. We can envision things, right? We can see the spatial quality of different spaces that we're designing. And a lot of our clients are just not like that. They don't get it, right? They're just not that inclined. And so to be able to take your model like this and without a ton of extra work, be able to show a client something like this, you know, a picture's worth 1,000 words. Immediately they get it, right? So whenever I'm, you know, working on a project and my client's like, I don't see it, I don't know. You're like, no, it's really going to be great. And they're like, I don't know. The second you show them the model, they immediately get it. You're like, oh, yeah, that is great. I should have taken your word for it, right? So we do have the ability to render in here as well, okay? We also have the ability, which in AutoCAD there is some of this capability, but we also have the ability to have all of our drawing sheets in here as well. All right, so we have the ability to build our model, to view it differently, to get different drawings from it, and then we have the ability to put a title block on it and print it all from the same file. Okay, very, very powerful tool, right? Out in industry, it's kind of funny. You have your Revit haters and you have your AutoCAD haters and you have your Revit lovers and your AutoCAD lovers, whatever. But it just, you know, one of the things that I used AutoCAD for a really long time in industry, right? I probably learned AutoCAD a really, really long time ago. And I love AutoCAD. I love the workflow. I love the drafting workflow. I think it's very quick to create things. But, you know, some of the things that Revit solves that AutoCAD has a problem with are so wonderful that when I sort of realized that I really liked Revit when I was working on a project on my own, and I thought, I'm starting this project in Revit because it's going to be a lot easier to generate drawings, some quick drawings. You know, it'll be quicker for me. And so, you know, there's just some really great things about Revit, and this is one of them. I really like that it's all very self-contained, right? We have all of the things that we need in one file. There's no closing out of one file, opening up another, making changes, closing it out, saving, opening the original file to go back and do what I need to do, right? There's also no XREFs, which are wonderful. It was a great system and it works very well, right? But it's buggy. It's very buggy at times if you're not working in an office where you're stationary all the time. And what I like about Revit is that everything is sort of self-contained here, right? I don't have 30 different files that I have to XREF into one file to then be able to print. I have everything here and I can organize it all in sheets and it can all be in the same file. Now, it gets very complicated when you get a big project, right? So it does get very complicated. But the system is just very nice and it's all very self-contained. Okay. All right. So any questions on what BIM software is and how that functions or anything? Yep.
So when you say you're
Mm. Right. That's a good question, right? It's a right. So when we talk about architectural elevations, this is the north elevation. So we are on the north side of the project. We're actually viewing south, but because we're on the north side, it's the north elevation.
Facing the north side of the house.
Right. You're on the north side of the house. Even though you're viewing south, it's still the north elevation because you're on the north side of the project. Yep, exactly. So it's north, east, south, west elevations. Yep. All right. Okay, so that's BIM software. A couple other things I want to talk about with regards to a few of the building elements in here, right? We've talked about creating this 3D model. We've talked about walls. We can see the roof. We can see, a few of those things. But I also kind of want to make a point to let you know. Let me create a little section region here. Where's my section region? Hold on. I've got it hidden from me. Okay. That we have kind of not just the major building components that are important in this model, I guess is a good way of saying it. Let me get this moving in a little bit. Within our projects here, see I'm kind of sectioning this off. We're looking at a 3D section of this. I keep losing my little grip. There it is right there. Not only do we have three-dimensional items like walls and floors and roofs, right? But we also have three-dimensional objects like doors and windows and furniture and different things like that, right? So when you're drawing in AutoCAD, not only are you drawing all of your walls and kind of major architectural elements with using lines, but you're also drawing minor architectural elements, or we'll say medium importance architectural elements with lines. And you're taking them and you're gluing them together in the form of a block, right? That has a certain definition associated with it. Now, within Revit, we have those same items. They're called families. They're not called blocks. They're called families or components in Revit. But we have kind of these mini defined models within the major model. So we have doors, right? There's a door. When I click on the door, it's all one piece, right? I can move it within the model, right? And the walls move around it. It has a relationship with the building that it's hosted into. I have a tub here that's being cut in sectional view. But I have, it's furniture. We have plumbing fixtures. We have toilets. We have cabinets down here. We have a sink. We have a little faucet, right? We have a hood right here. We have chairs, tables. We have a lot of kind of mini models that we put into our major Revit model to make it function, right? And look like an architectural model, which is really, really nice. For any of you who've used blocks for an extensive amount of time, right? They're not hard to generate. There's a lot of drawing associated with them, and there's a lot of lines, right? So it's really nice that I can just go and I can load in or inherently have built into the model these doors, windows, furniture, plumbing fixtures, right? All these things that just kind of go into the model very seamlessly, and they're all sort of self-contained. All right. Final great thing about Revit, right? It's really easy to coordinate with design consultants using Revit. We use what's called a linked system, okay? And it's not terribly different from an XREF system, right? So you don't get completely away from that system if you move away from AutoCAD. But you are able to give your model as the architect, right? You're able to give your model to your design consultants. And they are able to use that information to create their models. So when you work with an electrical, a mechanical, structural engineers, you create the base design geometry, the design intent in your model, and then they take it and they create their model, right? And the systems work back and forth. So you make changes to your model, you give it to them, it updates, they can update their work and send it back over to you. So it's the system is very easy. It's easy to coordinate with your design consultants using Revit, okay? And again, it uses a link system. We won't really get into that in this class, but they are able to use your work and you're able to use their work, and you can see everything in the model that needs to be seen, essentially, okay? All right, so what I'm going to do next is I'm going to save this file. So I'm going to just do a quick save up here, which you guys don't worry too much about this. I'm going to go to my desktop. I'm going to create a new folder. I'm going to open this up and I'm going to call this example. And I'm going to hit save. And I'm just going to save it a couple. I'm going to maybe move around a little bit. Maybe I delete a tree. And I'm going to hit save again, save again, save again. I'm just going to continue to save a few times because I want to show you the file structure of a Revit project. Okay. Let's go here to my desktop. So I've just saved my Revit file and I've hit save a few times as if I were working through a project, right? And in this folder called 2019 Revit, I'm going to open it up. Oh, we have a lot. Okay, that's a good illustration of what not to do. And we need to show our extensions. There we go. Okay. So when we're working with a Revit file structure as opposed to an AutoCAD file structure, we are generally working with one file, and that one file self-contains everything that we need to work with. It has our model, right? It has all of our families, generally. We can download things into it, but most of our families and components. It has all of our annotation capability, and it has all of our sheets contained. So when you're working in Revit, you're only using one file, all right? That one file is an RVT file. Okay, so you can see that. Let me see if I can, Nope. A working Revit file is a .rvt extension. Okay, so these other files that have generated, and when we start working in Revit, I'll show you how to control these a little bit better. These are backup files. All right, so we have our working Revit file, and then we have our backup files of that current file. All right, here's the one thing that I really don't like about Revit. I don't like that, and this is something I've researched, that they keep your backup files in the same place as your working file. I don't like that it has the identical extension that your working file has. And you can't change where to save them, essentially. Okay, so I know the difference between a Revit working file .rvt and a backup file is really that there is this 4-digit numeric naming system that gets input into the backup file. And that's really it, right? So when I'm in my working Revit file, every time I hit save, a new backup file is generated and it saves over the previous backup file. This one has been specified to have 10 backup files. So if I come in here back to my Revit file and I hit save a few more times, Control S, I'm just hitting save, right? Let's let it go for a second here. And then I go back to my folder system here, right? You see that before I think it was 1 through or 2 through 11 or something. Now it's 16 through 25. Okay, so every time you hit save, Revit saves over kind of the oldest version of your backup file system. Okay, so I like that we have backups. I don't like that they're in the same place as the Revit working file. I don't like that they have the same extension. It gets very confusing. And I've fallen victim to this, and I'm very, very careful usually with my file structure. But I have fallen victim to the fact that to restore a backup file in Revit, all you have to do is double click on one of these backup files, click, and it will open it. And you're like, oh, look, here I am. I'm in my Revit file. I'm working, right? And you hit save. And then all of a sudden, this one gave me a warning, which it didn't always used to do. And sometimes you aren't paying attention. You hit save, you walk away, you just hit yes, yes, yes. And then all of a sudden, a previous version of your Revit model has now become your current version of your Revit model, right? So what happened to me last year, I was working on a project, and I don't remember what happened. I think, because this can happen very easily, where you're like, I know it was the last one, and you double click on it and you open it and you go to work, right? When in fact, maybe somebody did that, you know, like your husband came along and was messing around with your files, and all of a sudden your working file's at the top, it's not at the bottom, right? So you come in and you double click on something you thought was your working file, open it without having all of your information completely viewable, you hit save, and then it wipes out, you know, all the work that you've done. Or there's what's called the, I'm going to close this out here real quick. We have our quick access menu here, where if I just click on a picture or an image right here of a file, it will open that up for working, right? But if I've accidentally opened up a backup, okay, and not my working file. If I click here and I hit save, it will wipe out my original working file. Okay, so I guess my point with this long explanation is that be careful when you're working with your Revit files. Make sure that you always open up your current working file. Don't open up, a backup file. Don't name your file with a number in it, right? I know it's really sort of tempting if you want to date something like 01/06/2018. We're in 2019, whatever year it is, right? You want to put a date on it. But when you do that kind of thing, it just sort of makes this process even more difficult. What I would like to see happen is Revit eventually allow you to route these to a different folder so that you could have a folder in here called backups. So that every time it backed up, it would go to a separate folder. So there was less of a chance for you to open up, previous backup files. Anyway, so this is what our Revit working file looks like. If you have a number in it, that is a backup file. Don't open backup files. Always open up your working file to work. Okay. Let's see. So we've talked about BIM software. You've looked at the model. I've showed you how you extract drawings from the model using views, right? You view the model differently to see different drawings in there. Let's see. I've kind of talked about how we have what's called the project browser over here. I might not have named it, but we have what's called the project browser over here, and this organizes all the different drawings within your Revit file. We've talked about how BIM software is different than regular 2D drafting software, right, than AutoCAD. It's three-dimensional, it has defined elements in it, there's information in it. A 2D drafting software like AutoCAD, you have 2D flat lines that represent things. They're not defined as things, they represent things, okay? Okay, just a couple of definitions that I want to make clear, and I'm going to try and split my screen here so that we can look at a sheet of definitions, and then I want to show you them in Revit. So let me see if I can effectively do this. There we go. Okay. All right, so we have some different definitions in here that I'm going to talk about, okay? We have our project, all right? Our Revit project is that .rvt file, and when you say I'm working on a Revit project, that is your three-dimensional model, essentially, right? It's that one file that contains everything. That's your Revit project. Let's see, project template. We haven't gotten to project templates yet, but we will. Revit has, I think, 4 or 5 different inherent built-in project templates for you to use. And the project templates are a starting point for a new Revit project for you. All right, so in AutoCAD, we didn't have a template. When you first started using AutoCAD, it was a completely blank file. There was no definition in it, right? So AutoCAD, extremely generic. You go in, you create a template that you can then use to start working, right? And what that means is you define dimension styles, text styles, you define layers, you define pages, you define blocks. There's probably 10 different things that you predefine in your AutoCAD template so that when you go to work, everything is there available for you to start working with. Revit's kind of gotten smart and said, hey, we know that they're, architectural discipline, generally they need a few of these wall types. They need a title block. They need, floor plans made. So Revit has created some generic templates per discipline for you to use to start a project, okay? So we will talk, I'll show you, we've talked about them, but I'll show you how to use those probably next time. Host. So a host in Revit, let me go to a three-dimensional view here. Oop, it's hiding from me. There we go. So a host is a model element that will accept or host other elements into it. So if you were to generically define these, they would be major architectural elements. Hosts in Revit are generally major architectural elements. So things like walls, floors, roofs, those would be considered hosting elements, and they host smaller model elements and components such as doors and windows and furniture, right? So host would be something like a floor, and a model component that hosts onto a floor would be furniture, Okay, another host in Revit would be a wall, and things that host into a wall would be doors and windows. Okay, so the host is a model element that accepts or hosts other elements into it, and model components, they're all of the other types of elements in your models except hosting elements. Okay, these will all become very evident once we start working in the model, but it's nice to know what the actual definition is. We have annotation, which are 2D elements such as dimensions and keynotes and tags and text and detail lines. So annotation adds kind of verbal or graphic description to elements in the model. All right. So when I'm looking at a level 1 floor plan here, you know, a piece of annotation would be like this room tag. Okay, so it gives a verbal and graphic description of the space. You know, we could guess that this is the kitchen, but what if it's the lounge, right? So we need annotation to tell us what things are in the model. We also have levels in our model. This is something that in AutoCAD we sort of have implied, but not that we define necessarily. This is all metric, of course, but levels are infinite horizontal planes in Revit that organize a Revit model vertically. All right, you're going to find that there's a lot of definition in Revit when we get into it, and one of those definitions is defining a base constraint and a top constraint for elements. We need to tell things in Revit how tall they are, where they start, where they stop. And so these datums, these vertical datums, or these levels, this is how we do that. That's the system we use. Okay. Levels are also, they define different drawings in our projects. So for example, you'll see that we have level 1 right here. Oh, look at that. We have level 1 over here, right? So floor plan level 1, we define it with a level, and it shows up as a drawing level 1 over here in our project browser. Don't worry, it'll all make sense eventually. And then we have families. Families are going to be the same thing as a block in AutoCAD. And families are groups of elements with a common set of parameters. So a really good example of a family is a door, right? So it has a frame, it has a panel, it has a doorknob. They're all separate elements, but they all combine to create one object, right? A family. The term family or component might be used to describe these things. So if I say use a component, it's the same thing as if I would have said go and find that family, right? Family, component, the terms are used interchangeably in Revit. All right, a couple more things here. And this likely won't make a whole lot of sense until we get into the actual usage of Revit. But I want to define the idea of type versus instance in Revit. All right. We have type, okay? And a type is a specific item such as, and one item can have several different types. So for example, right, if I come into my 3D model here, okay. I'm going to come over here. Let's see if I can get a window. And let me just say blanketly that these apply to all elements in Revit. So it's not just specific to a host like a wall or a component like a door or a window. These terms are specific to everything in Revit. So I can have a type of something, or I can have an instance-based type of something. So a type is a specific item, and one item can have several different types. So if I click on this window, okay, it's called a single window standard. And if I click on the down arrow here, you see that, well, I only have one here. Sorry, this is kind of a bad example. But generally, a different type would be another size. So I have a type of an item, which could be a door, but then I have several different other types that are the same as that type, but have different dimensions to it. Like we have a 3 foot by 8 foot door. We have a 2 foot 6 by 8 foot door. We have a 2 foot by 8 foot door, right? We have a 4 foot by 8 foot door. Okay, so that is a type. We have a type of window, and we can have several different types of that window based on dimension. All right. I also have instances. Now, when I talk about the word type, okay, if I make changes to a type, it affects every type of that object. Again, these are probably pretty confusing, but they'll make sense when we get into the software. So for example, if I have this window and it's called Single Window Standard, and I hit Edit, Type, and I change something about it, like maybe, I don't even write this all metric, but if I change something about it, maybe we change that to 70, and I hit OK. Did you see how maybe very slightly, if you were quick watching all three of these windows, they all three changed? If I make a change to a type of something, every type changes. It's like a block. If I edit a block, every other block in your project with that same name is changed when I edit that block, the original block, okay? So type is sort of like a block. If I change a type, it changes every type of that named instance. Or that same type, I guess I should have said. Which is different from instance, okay? An instance, they are individual elements in a project, and they function uniquely, all right? So if I have, 1, 2, 3 different windows here, and I make a change to the type, that change is mirrored through all of the all the types of that window. If I have a separate instance of that window, okay, and I make a change to that instance, it will only change that one instance of that window. Again, very confusing saying it, but when you actually see it functioning, when we get going, it'll make a lot of sense, all right? So there are objects where if you change one of it changes everything, and there are objects basically where if you change, that one instance, it is defined so it only changes that one instance, okay? All right. Just like AutoCAD, so I'm going to make this larger, and then I'm going to make this a little bit larger. Just like in AutoCAD, Revit's interface will allow you to use the icons within the ribbon to function, but it will also allow you to use the keyboard. Okay, so I've listed probably, there's a lot here. How many pages? 1, 2, 3. And I cut this down from like 10 pages probably. But I chose probably my most used keyboard shortcuts for Revit. So for example, when you want to create a line in AutoCAD, you hit L, right? L, enter, and you go and you draw your line. In Revit, you don't draw lines, you create walls, right? And the command for creating a wall is WA, right? So same idea, it just functions a little bit differently. And I'll show you where these keyboard shortcuts can be found within the software and how you can change them and modify them and make them work for you, essentially. But I just want to make the point that we do have keyboard shortcuts in addition to all of the different icons that we can use to generate geometry in Revit. Okay. All right. Any questions so far? Not terrible, right? Not yet. All right. Okay, I think we've gone through most of this, but I'm just going to show you this graphic. This is in the project manual here, right? So just in case you are a little confused on what different things might be, right? I've defined what some of probably the most common things that you'll see in Revit, what they are. So number 1 is a grid line. Here's number 1. Number 2 is a dimension. We know that. Number 3 is going to be storefront glazing. That's what that looks like. Number 4 is a level, right? So we talked about that. Levels define vertical elements in Revit. Number 5 is a wall. Walls are hosting elements. Number 6 is a door. Okay, a door is a hosted element that can be hosted into something like a wall. Number 7, this is a topographic surface, right, or topography. Number 8 is our roof. We've got our roof here. The roof is a hosting element. It can host things like skylights or mechanical equipment or whatever. Okay, and then we have number 8. We have a typo, number 9, which is a floor right there, okay? A floor is also a hosting element, and it can host things like equipment or furniture or whatever goes on a floor, okay? So that is in there just in case you want to look at it. Okay. Any questions so far? All right. Let's see here. I'm going to let me pop back over to my canvas here. That's all I have for module 1. Oops. Is just kind of the introduction to the software, talking about terms, showing you what the different file structures are. And I think we can probably stop there, actually, for today. Okay, I'm going to stop my video.